section 5.2 is talking about transformations in sine functions. So this is exactly what we've talked about before. It's just with sine graphs or cos graphs. Okay, so on the top of your notes, okay, so here's our equation, and it works the same. You have one cos and one sine one on your page. These all work the same as the transformations we've done before. Okay, so here, this is the amplitude, but in other words, that's stretching your picture, right? That's a vertical stretch. If there was a negative in front, then your picture is going to open down like a reflection. Okay. This is our period length, and before we would know that as a horizontal stretch, right? But for our period length, it just tells you if it's getting longer period length or shorter, like if it's stretching it or compressing it. So it's doing the same thing. So we know this is our period length, 2 pi over b, and we can also call that a horizontal stretch. Okay, and in here, anything in the brackets affecting your x's, so this is our horizontal translation left or right. Okay, and it still works the same. If it's negative, it's going right. If it's positive, it's going left. Okay. And then the last part is our vertical translation, up or down. Okay, and I know you have a cos example right below it. It's exactly the same if it's cos. Okay, the only difference with cos is you start your drawing at the amp, and with sine you started at the origin. Okay, so example 1 says we're going to sketch this equation, and it's a sine x minus 30 degrees plus 3. Okay, so we're going to sketch that, and then we're going to say what the domain and range are, and we can say, using transformation language, what happened. Okay? So keep in mind, if I was drawing just the original, remember an original looks like this, meaning your amp is 1, your period length is 2 pi, you have 4 movements, right? So if I drew the original, it would be half pi, pi, 1.5 pi, 2 pi, and then 1 and minus 1. And you'd start at the origin and you'd go up, back, down, back. Okay, so keep in mind this is the original. That's usually what an original sine equation looks like. In this case, we have this, so that is what? Yeah, horizontal. Did I spell that wrong? So of 30 degrees, and so that means we're going right, because it's negative. Okay, this means we have a vertical translation, up 3. Okay, in front of here is just 1, so our amp is 1. And in front of here is just a 1, so our period is 2 pi. 30 degrees, yeah. And technically I should have these in degrees because we're shifting in degrees. Okay, so I can change that up. 2 pi, sorry. So then if our normal shifts were like, we end at 360, right? No, yeah. 2 pi is 360, 180, this is 270, and this is 90. Okay, and if you notice, we're shifting 30 degrees over. So that should be like, I might have to do a nicer picture. Okay, so usually we have 4 movements, right? And I just said this was 90, 180, 270, and 360. Okay, but if we're shifting 30 to the left, no, were we shifting to the left or right? Right. 30 to the right, we're not going to shift a full tick here, right? Because these are by 90s. So if you think this is 30, 60, 90, and then 120, 150, 180, and 180, 210, 240, 270. Okay, so I'm just throwing extra ticks in there so that you can see where that 30 shift's going to come in. 300, 330, 360. Okay, so again, I said our original picture was this, and then we went up, back, down, and back. Okay, so here was our original. Oop, it's ugly. It's okay. And then now our new one says we're shifting right 30 degrees and we're going up 3. So we're shifting every point 1 spot over because these are all 30 ticks now, right? 30, 60, 90. So this tick would be here now. This one would be 1 over. This one would be here. This one would be here. And this one would be 1 more over that way. Okay, and then we're also going 3 up, right? So if we're going 3 up, this point was here, and now we want to go 3 up. 1, 2, 3. It should be at 3 there. Okay, this guy was at 1, and we're going 3 up. 1, 2, 3 up. This guy was here, so 3 up. This guy was 1 below, so he'll be at 2. And this guy, 3 up. So then when we draw it, it's ugly, but that's what it looks like. We shifted it over 30 and we moved it up 3. Example number 2 is a coast graph. So we are doing -2 cos. Then in the bracket, they have this sign. It's the same of having it x. Plus pi. Subtract 1. Okay, so let's just label all the things that are going to happen here. What's this negative mean? Yeah, we're going to have a reflection. What about this 2? So our amp is going to equal 2. Remember, it's never going to equal -2. It's not a negative amp. This is a horizontal shift. So pi to the left, right? Or pi to the left, correct? And then this one is vertical translation down, right? And let's just keep in mind, remember this is a 1 in front of here, so our period length is still going to be 2 pi over b. B is 1, so it's going to be 2 pi. Okay, so I'll just start by drawing a normal coast graph. Okay. Okay, so a normal coast graph, you would be starting at your amplitude, and remember we said it's half pi, pi, 1.5 pi, 2 pi, because our period length is 2 pi. Okay, so a normal coast graph, I start up high at my amp, I come down, I go under, I go back, and then I go above. So it looks like this. Okay, so this is my normal. This is just a y equals cos x. Just a normal, like nothing happened. That's standard picture. Okay, so now we have to keep in mind this is going to open down. It's going to have an amplitude of 2, and we're shifting it pi over. Okay, so let's just do these first two things first. A -2. Make the amplitude 2, and starting down below, so our amp is 2, -2. So we'd be starting here, and then we'd come to here, 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 and here. Okay, so that is if it has a reflection and an amp of 2. Okay, and now it still has to move to the left a pi, so that's 2 big ticks over, right? Because these are half pi ticks. So we got to move 2 full ticks over and 1 tick up. Okay. Well, you can draw it. I'll just change the color. I'll draw the final one. Okay, so here's another tick. We'll say this is 3. Okay, so we are going over, remember, we're going over by pi, and we're going down by 1. So this point here is now over and down, so it'll be here. Oh, sorry, that wasn't our first point. I should be starting here. Oh, what am I doing? That doesn't work. Okay, there we go. Okay, so this one is over to pi and down 1, so it should be here. Okay, so we're at -3. And then this one is over 1, 2, and down 1. Okay, so we're like this right now. This point is over 2 ticks, 1, 2 ticks, and down 1. So we're here. Okay, whoops, that should be kind of right on the axis. This guy is over 2 ticks and down 1. It shouldn't look any smaller. I think it's just because my pictures, right? And then this guy is 1, 2 over and down 1. Okay. So that is, it shifted over a pi to the left and down 1. Okay, so the next example, I don't know if I'm going to draw the full example, we'll see as we go, but I just want to show you how this one works because it looks a little bit different. Here's our equation. And if you notice, the 2 is on the inside with the x. And before, when we've had shifting in that, you know we have to take that out before we start. Is that a +2 with it on the end? Okay, so we don't want this 2 here, so we're going to be dividing by 2. Okay? So that means we're dividing this by 2. So we're dividing a fraction by 2 means we're actually multiplying by, because this is like a 2 over 1. We'll multiply by a half to get rid of it. So I'll multiply by a half in the top and in the bottom. Okay, so that means these 2's are gone. So what this looks like when it's simplified is the 2 is now on the outside. We have the x, and now we're left with a pi third with the plus 2 at the end. Okay, so now this is meaning that our amp is 3. Our period length is 2 pi over b, and our b being 2. So our period length is just pi here. This is a horizontal shift. And we're going right a third. And this is a vertical shift up 2. Okay, so we have to keep in mind that our period length is pi, but we want to go thirds, right? So I made 12 ticks just so that, or I went by 12ths so that I would have a third in there, okay? Because otherwise it won't work out evenly. So I just made my ticks like pi over 12. 2 pi over 12 is a sixth. 3 pi over 12 is a half. 4 pi over 12 is a third. 5 pi over 12. 6 pi over 12 is half. Okay, so then I did this all the way to 1 full pi, just so that I had a third marked on here, so that I know that I have to move 1, 2, 3, 4 ticks for my shift. Okay? 1, 2, 3, 4. Like, so my last tick is like 12 over 12, which is pi. Okay? So then my original picture, 7 pi over 12, 8 pi over 12, and you can reduce these if you want, 9 pi over 12, 10, 11, so then this is the end of our period, right? I'll switch my, this is the end, this is halfway, and so we would have been 1, 2, 3 up, and then halfway in between here, you're up, and halfway in between here, you're down 3. Okay, so all I did was draw the original with an amplitude of 3. And then we would be shifting a third over and then 2 up. So all of our points, a third is 4 points. So you'd be going 1, 2, 3, 4, and this would now be that point. Okay, and you shift them all over. What's that? This is a third, see? Pi over a third. So you'd have to move it, that's 1, 2, 3, 4 ticks. All of your points are going to go 4 ticks. Whoops, sorry, did I move it the wrong way? It's got to go to the right, right? So this one would be 1, 2, 3, 4. This one would be 1, 2, 3, 4. And you'd move them all. Plus, you got to move them 2 up. Okay. This point is 3 over 12 pi, sorry. So it's technically like pi over 4. I had it as pi over 2. Make sure you make that correction. Okay, and then our last example has a graph, and you're creating an equation from that. Okay, this is going to be more hard because I got to draw this picture out. But okay, this is what it looks like. And right here, this is 2 pi over 3. And that was pi, I think. Okay, so what I noticed is it looks like it shifted up, right? Because it should go up and then down below and then back. And it's saying you want to make a cos one and you want to make a sine one. Okay, so I just marked off the points. So here was at 2, I believe. And then there was a point here, here, and then here. Okay, I marked that off as if I was doing a cos equation. Because if this was shifted down 2, we would be back at our baseline, right? Because right now we're at 4, and our lowest is 0. So remember when I said to find max or min, you could go, which was the equation for that? Does anybody have their notes out? Just looking at this is 4 and we're at 0. So the midline is where? The midline should be at 2. Do you know what I mean? Like that's what this line should have been originally. So it looks like that we shifted up 2 spots. Okay, so say we have this cos equation. It looks like we went up 2. Okay? Because technically this should be here, and then here, and then above, and then here, and then here. Right? Okay, and if you notice, we started upside down also, right? So our amplitude should be 2, -2, right, because we started upside down. Okay, and did we shift anywhere, really? No. So we could leave our equation like this, but then we got to figure out the period length. Like this is one full movement here, this 2 pi over 3, right? Because we went here, 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 here. And then it would repeat again. So our period here is 2 pi over 3. And the question is, remember we know that 2 pi over b is how you find your period length, right? So b is how much then? 3. Okay, because look at 2 pi, 3, and b. Okay, and if you don't see it just visually like this, like 3 is equal to b, then you can also cross multiply and solve. That's usually how I find it, because sometimes it's not as easy as just seeing it. So I'd go 3 times 2 pi is 6 pi, and then I'd go 2 pi times b, divide by 2 pi, divide by 2 pi, and I get b is equal to 3. So in my equation here, I should have 3x, because that's what my period length is.